We are now going to talk about measuring center. So if you remember in the previous section, we had 4 things that we look at when we look at distributions. We discussed shape a little bit. Now we're going to talk about center, and then we're going to talk about spread and outliers. So for center, we have 2 major ways that we measure it. The first one is the median, which I think many of you have heard before as the middle number. And if you did that before in like elementary school or middle school, it hasn't changed. Second one is the mean. Once again, if you did that in elementary school or middle school, it hasn't changed. The only difference for mean is I'm actually going to give you a notation for it that you probably haven't seen before. So we usually see the mean written as X bar. Sometimes you'll see it as Y bar, but the main thing is it's going to be a variable with a bar over it. I'm also going to show you the formula that we would use for mean. You do not need to memorize this because it looks really confusing. So the mean formula is going to be the sum of all of your values, which I'm going to call xi, over the number of values. So this one is a fancy notation to write add up all the numbers and divide by the number of values. I'm going to say add up all the values. So, despite the confusing looking formula, it's the exact same thing. If you want to forget this formula ever existed, that's fine. But you do need to know this X bar notation. That's important to know. Okay, so 3 important things. Let's say that you have a histogram and it's mostly symmetric. So if you have a graph that is symmetric, then in general, the mean is going to be approximately equal to the median. So now the other 2 are ones that you need to know, but they're a little bit more confusing. If you have a graph that's skewed left. Now remember, skewed left means you have lots of values on the right-hand side, and you have a tail on the left-hand side. What's going to happen is your median is going to be probably somewhere like in this area up here, but your mean is going to bring everything down. So your median will be all the way up here, but the mean usually is going to be a little bit lower. The mean actually, you'll have a few values here that bring down your mean. So these low values will make the mean go down. So what's going to happen is your mean is going to be less than your median. The next one is skewed right. I'll draw a picture. So skewed right means you have a lot of values on the left-hand side, and then you have a few values right here. And a good example of this type of thing is like house prices. Most people are in the left-hand part of this, so like your median is going to be around here. But there's going to be a few people with really, really expensive homes on the right-hand side that are going to pull the mean up. So what's going to happen is your mean is going to be greater than your median. So let's do an example. The first thing I'm going to ask you for is the mean. So the mean you will find by just adding up all of these numbers and then dividing by the number of values that you have, which is 9. And remember that we write it as x bar, so we will find that our mean, or our x bar, will be approximately 20. I'm going to actually round it to 2 decimal places, so it'll be 19.89 grams of fat. Now, the median, as I said before, this is the same thing you saw back in elementary school. All the median is your middle number. So our median is this guy right here. It's going to be 19. And if you want to use the stuff that we talked about on the previous slide, you will see that the mean is bigger than your median, which means you probably have some large values pulling the mean up a little bit. And I think that 33 would be the large value that pulls them up. It's not a major difference though, but we can say that it probably is a slightly right skewed distribution. If you want to draw it, go ahead and you can see. If you draw it and want to come back and show it to me tomorrow, I will give you a sticker. And so go for it if you have some time. So now the next thing I'm going to ask you to find is what's called the 5-number summary. I have a feeling that this is probably new for most of you. So our 5-number summary is going to include the minimum. The second thing is what we call the first quartile, which I'm now going to abbreviate as Q1, followed by the median. Then the third quartile, which you can abbreviate as Q3, followed by the maximum. So median we already found. We know it's 19. We got that in the previous example. Minimum and maximum are pretty easy. It's 9 and 33. Our quartiles are a little harder, but not impossibly so. So our third quartile is going to be found by looking at the upper half of our values, and the first quartile is going to be found by looking at the lower half. So my third quartile I find by looking at trying to find the median of these 4 numbers. And when you have 2 numbers when you have an even number of numbers there's a few ways to find this. I'm just going to find the average of 22 and 27, which I do by adding them up and dividing by 2. That gives me 49 over 2, which ends up giving me a third quartile of 24.5. First quartile is going to be the median of the lower half of numbers, and that's going to be 15. So this is my 5-number summary. And this is going to be important in the future when we draw what's called a box plot.